Newton's third law of motion. The second law relates the external force on a body to its acceleration. What is the origin of the external force on the body? What agency provides the external force? The simple answer in Newtonian mechanics is that the external force on a body always arises due to some other body. Consider a pair of bodies A and B. B gives rise to an external force on A. A natural question is, does A in turn gives rise to an external force on B? In some examples, the answer seems clear. If you press a coiled spring, the spring is compressed by a force of your hand. The compressed spring in turn exerts a force on your hand and you can feel it. But what if the bodies are not in contact? The earth pulls a stone downwards due to gravity. Does the stone exert a force on the earth? The answer is not obvious since we hardly see the effect of stone on the earth. The answer according to Newton is yes. The stone does exert an equal and opposite force on the earth. We do not notice it since the earth is very massive and the effect of small force on its motion is negligible. Thus, according to Newtonian mechanics, force never occurs singly in nature. Force is the mutual interaction between two bodies. Forces always occur in pairs. Further, the mutual forces between two bodies are always equal and opposite. This idea was expressed by Newton in the form of the third law of motion. To every action, there is always an equal and opposite reaction. Newton's wording of the third law is so crisp and beautiful that it has become a part of common language. For the same reason, perhaps misconceptions about the third law abound. Let us note some important points about the third law, particularly in regard to the usage of the terms action and reaction. The terms action and reaction in the third law mean nothing else but force. Using different terms for the same physical concept can sometimes be confusing. A simple and clear way of stating the third law is as follows. Forces always occur in pairs. Force on a body A by B is equal and opposite to the force on the body B by A. 2. The term action and reaction in the third law may give a wrong impression that action comes before reaction, that is, action is a cause and reaction is the effect. There is no cause-effect relation implied in the third law. The force on A by B and the force on B by A act at the same instant. By the same reasoning, any one of them may be called action and the other reaction. 3. Action and reaction forces act on different bodies, not on the same body. Consider a pair of bodies A and B. According to the third law, FAB equals minus FBA. Force on A by B equals negative of force on B by A. Thus, if we are considering the motion of any one body A or B, only one of the two forces is relevant. It is an error to add up the two forces and claim that the net force is zero. However, if you are considering the system of two bodies as a whole, FAB and FBA are internal forces of the system, A plus B. They add up to give a null force. Internal forces in a body or a system of particles thus cancel away in pairs. This is an important fact that enables the second law to be applicable to a body or a system of particles. See chapter 7.